Settle in for a little while. There is nothing here that needs to be solved tonight. Nothing to remember, nothing to do. You can let your shoulders soften, let your breathing slow, and let the sound of these words become a kind of quiet companion as we wander together, very gently through the largest and smallest places that exist. We are going to take a long, slow journey, and there is no hurry at all. If you drift off somewhere along the way, that is perfectly fine. The universe will still be here, patient as ever, when you wake. Let us begin with something small and ordinary. Imagine you are sitting on a beach at the close of day, when the light has gone soft and golden, and you reach down and gather a handful of warm sand. The grains slip a little between your fingers, fine and pale, almost weightless. If you were patient and the evening was long, you might try to count them. After a great deal of time, you might reach a few thousand before the numbers blurred together and your attention drifted out toward the water. A single handful of sand, a few thousand tiny grains. Hold that picture gently in your mind. Now imagine that each of those grains is not sand at all, but an entire star, a sun like our own, burning quietly in the dark. To count all the stars that exist, you would need far more than a single handful. You would need that whole beach, every grain along its length, and even that would not be enough. If you gathered the sand from every beach on Earth, from every shoreline of every ocean, and counted each grain one by one, you would still fall short of the number of stars scattered across the universe. There simply is not enough sand on our entire world to match the lights in the sky. That is the kind of bigness we are going to spend this time exploring, and it is so vast that no mind, however clever, can truly hold it all at once. In the rush of ordinary days, we tend to forget this. We move through kitchens and streets and rooms, and the scale of things shrinks down to whatever is in front of us. A doorway, a cup, the distance to the shop on the corner. And there is nothing wrong with that. It is how we are built to live. But tonight, we are going to step outside that small and comfortable scale, very softly, and let our imagination stretch out in every direction until it reaches places where the ordinary rules of near and far begin to dissolve. We will travel down into the heart of matter, into a world so tiny that distance itself loses its meaning, and we will travel outward into structure so enormous that light, the swiftest thing in all of nature, takes billions of years to cross from one edge to the other. Before we go anywhere, it helps to make peace with a strange and quiet truth. Our senses, as faithful as they feel, are gentle liars. They were shaped over countless ages to help our ancestors survive on the surface of one small planet, to judge whether a river could be crossed, whether a hill could be climbed, whether a shape in the distance was friend or danger. For that work, our senses are wonderful, but they were never designed to measure the gulfs between galaxies, nor to peer into the spaces inside an atom. We live, you and I, on a kind of middle shelf of reality. To us, a mile is a comfortable thing, a walk we can picture. A mountain seems almost impossibly tall. Yet on the scale of the cosmos, the difference between a grain of dust and the highest mountain on Earth is almost nothing at all. Both are smaller than small. Both would vanish completely against the great backdrop of space. So when people say that the universe is large, they are not quite telling the truth, because the word large is far too gentle. We are speaking of a place so wide that light, which crosses the distance from the sun to your window in only a few minutes, must travel for billions of years to pass from one side of the visible cosmos to the other. Think of that slowly. The fastest thing that exists, the very speed limit of nature, set loose at the beginning of time, and even it has not had long enough to reach across everything we can see. that is not largeness in the way we usually mean it. It is something closer to a different country of the imagination, and we are about to visit it together. This will not be a journey of dramatic shocks or sudden surprises. We are not here to be startled. We are here to wander, the way you might wander through a great quiet museum late at night when the crowds have gone home and you can stand in front of each thing for as long as you like. We will begin in a place where the familiar rules of logic gently come apart, the world of the very small, the quantum world, and there we will go looking for the tiniest pieces that nature allows to exist, the invisible building blocks hidden inside everything you have ever touched. Then, when we have reached the bottom of smallness, we will turn around and begin the long, slow climb upward and outward. We will visit the stars that are our nearest neighbors, separated from us by chasms so wide that their light spends years simply reaching our eyes. We will drift past clouds where new stars are being born, past galaxies holding hundreds of billions of suns, all the way to the largest structures that human beings have ever managed to map. And at last we will arrive at the very edge of what we are able to see, the soft horizon of the observable universe, and we will rest there for a moment and look back at how far we have come. To begin, let us go downward into the small. To understand the greatest structures in existence, it helps first to understand what everything is made of, because the same simple pieces that build a galaxy also build your hand, your breath, and the bed you are lying on right now. So let your thoughts grow quiet, and let the ordinary cares of the day loosen their hold, one by one, the way a hand slowly opens. There is nothing you need to keep track of here. We will move slowly and gently, and if your attention wanders or drifts or fades entirely into sleep, that is perfectly all right. The journey will carry you regardless. We are simply going to follow the thread of size down to the smallest place there is, and then up and out to the largest, pausing wherever we like along the way. Picture yourself growing lighter and quieter and very still, ready to drift inward toward the heart of matter itself. Picture your own hand resting easily wherever it lies. It feels solid, continuous, warm. But suppose you could look at it through a microscope of impossible power, one that magnified more and more until the smooth surface of your skin broke apart into something else entirely. You would see that your hand is not a single solid thing at all. It is built from countless tiny structures called molecules, arranged and woven together in patterns of astonishing intricacy. These molecules are the first true building blocks of the things we can touch, and they are everywhere. They make up the solid floor and the liquid in your glass, and the very air drifting in and out of your lungs as you breathe, slowly in this quiet moment. Some molecules are wonderfully simple. Take water, the most familiar substance there is. A single molecule of water is nothing more than two small atoms of hydrogen joined to one atom of oxygen. Three little pieces clasped together, and yet that humble arrangement, repeated beyond counting, is enough to fill the oceans, to shape the clouds, to carve canyons over millions of years, and to keep every living thing alive. The bond that holds those three atoms together is quiet and strong and astonishingly stable, and from it comes nearly everything soft and flowing in the world. But the truly beautiful part of the story is not how these pieces hold together. It is where they came from. This is one of those gentle facts that once you really feel it, changes the way the night sky looks. Nothing you can see around you right now was present at the beginning of time. Not the iron threaded through your blood, not the calcium hardening your bones, not the gold in any ring, not the stone of any mountain. None of it existed when the universe was young. In its earliest moments, the cosmos was not a place of planets and stars and quiet bedrooms. It was something closer to a sea of pure energy, unimaginably hot, formless, simple. As the ages passed and that energy spread out and cooled, a little of it began to settle into matter, the way mist settles into droplets, and the very first stars slowly kindled in the dark. Those first stars were enormous, far larger than our sun, and inside their hearts something marvelous happened. Under crushing pressure and ferocious heat, the simplest atoms were forced together, melted and fused into heavier ones. The stars became, in a sense, vast and patient kitchens, cooking up the ingredients of everything that would ever follow. The oxygen you are breathing in this moment was made inside a star. The carbon woven through every cell of your body was made inside a star. The calcium in your bones, the iron in your blood, all of it was forged in the burning cores of suns that lived and died, long before the earth itself existed. And when those great early stars finally exhausted their fuel, they did not simply fade away. They ended their lives in tremendous explosions, the kind we call supernovae, and in that final brilliant breath, they flung all their freshly made ingredients out into the dark. Clouds of gas and dust spread across the emptiness, drifting and cooling for ages upon ages, until gravity gathered them together once more into new stars, new planets, and eventually, after a journey almost too long to imagine, into living things and into us. There is an old and gentle saying that we are made of star stuff. It can sound like a poetic flourish, a pretty turn of phrase, but it is meant quite literally. You are, in the most exact and physical sense, a child of the stars. Every atom in your body has traveled an unthinkable distance through space and time. Each one was born in a furnace among the early stars, survived the violence of an exploding sun, drifted through the cold dark for unimaginable stretches of time, and then, against all odds, came to rest here, woven into the quiet breathing person you are tonight. When you look at the periodic table of elements that sits in so many classrooms, that orderly chart of names and symbols, you are really looking at an inventory of everything the stars have ever made. It is a kind of family record, written in the language of matter, and your name is somewhere in it. In this way, we are the conscious legacy of stars that died before the world began. We are perhaps the way the universe has finally arranged itself so that it can look back upon its own face and wonder, quietly, what it is made of. Hold that thought softly for a moment, because it changes the way an ordinary body feels. The hand resting at your side was assembled, atom by atom, from the remnants of ancient suns. The breath moving slowly through you carries oxygen forged in stellar fire. You are not a thing apart from the universe, gazing at it from a safe distance. You are a piece of it that has, against all odds, woken up. The same material that drifts in the great clouds between the stars has gathered itself here, in this quiet room, into something that can feel the warmth of a blanket and the weight of tiredness at the end of a long day. There is no need to travel anywhere to touch the cosmos. You are already made of it through and through, from the marrow of your bones to the faint electrical whisper of your thoughts. The stars did not happen somewhere else, long ago, separate from you. They happened, and here you are, their gathered ash brought gently to life. But to understand how this star stuff manages to hold together, to keep its shape, to feel solid beneath us, we have to step it down one more level, into the very heart of matter itself. We have to enter the atom. The world feels firm beneath us. The floor holds, the walls stand, the cup keeps its shape in your hand. We move through our days entirely confident that solid things are solid. And yet this confidence rests on a misunderstanding, a gentle trick of the senses, because the truth of matter is far stranger and far emptier than it appears. Atoms make up the chair you might sit in, the page you might read, the bones that hold you upright, and yet an atom is almost entirely nothing at all. It is mostly empty space, an enormous quiet vacancy held in shape by invisible forces. This is difficult to picture, so let us build a slow image together and dwell in it for a moment. Imagine a vast stadium, the kind built to hold tens of thousands of people, with row upon row of seats rising up into the evening, and a wide green field at the center. Imagine standing alone in the middle of that field at night, with the whole great structure silent and empty around you. Now let the entire stadium represent a single atom. The whole thing, from the field at your feet to the highest seat far above, all of that is one atom. And the nucleus, the dense heart of the atom, where almost all of its weight is gathered, is nothing more than a tiny marble resting on the grass at the very center where you are standing. That small marble holds nearly all the mass of the entire stadium. It is made of tightly packed particles called protons and neutrons, crowded together so closely that the matter there is denser than anything in our ordinary experience. If you could somehow hold a piece of it in your palm, it would feel impossibly heavy for its size, far too heavy for something so small. But here is the quiet astonishment. Everything else in the stadium, all the rows of seats, the long sweeping aisles, the air filling the great open bowl above you, all of that is essentially empty. The other essential pieces of the atom, the electrons, are not seated neatly in the stands like a tidy crowd. They do not stay still at all. They move near the very outermost edges of the stadium, far from the marble at the center, drifting and flickering in patterns that no one can fully predict. Scientists call the regions where electrons are likely to be found their orbitals, but these are not solid tracks or fixed paths. They are more like soft clouds of possibility, blurred zones where an electron might appear at any instant and then be somewhere else entirely, the next moving so swiftly that together they form a kind of faint, restless shell around all that emptiness. That shell of electrons is the reason matter feels solid to us. When you press your hand against a tabletop, you are not actually touching the table at all, not in the way you imagine. You never quite reach it. What you feel is the gentle but firm refusal of the electrons in your skin to come any closer to the electrons in the wood. Like meets like, and they push softly apart. That faint, invisible pressure is what keeps your hand from passing straight through the table. What keeps you from sinking through the floor? What makes the whole world feel reliably there? The solidity of everything, in other words, is a kind of beautiful illusion woven from the restless dance of electrons that never quite let one another touch. Now consider just how much emptiness this means. The distance between that little marble at the center of the stadium and the electrons drifting near the highest seats is enormous compared to the marble itself. Almost the entire atom is open space. If you could somehow remove all that emptiness from the atoms in a human body, pressing the dense nuclei together with nothing between them, the whole person could be squeezed into something hardly larger than a single grain of salt. And yet it would still weigh exactly the same. Everything that gives us bulk, height, the comfortable space we take up in a room, all of it is mostly void, held open by invisible hands. It is a strangely peaceful thought if you let it settle. You are, in the most literal sense, mostly empty space, gently arranged around a scattering of tiny dense points, and held together not by solid stuff, but by quiet forces that never rest. The chair holds you, the bed holds you, the ground holds you, not because matter is hard, but because countless electrons are forever refusing, very politely, to crowd one another. Without that balance, the dense little nuclei at the center and the restless electrons at the edges, nothing in the world would behave the way it does. Chairs would not hold, walls would not stop us, the warmth of a sunny afternoon would have nowhere to land. Even that warmth, when you feel it on your face, is only those tiny pieces of matter trembling and bumping a little more eagerly against your skin. The temperature of a thing is simply how briskly its atoms are dancing. There is a soft and restful comfort hidden in all of this, if you let your mind settle into it. The bed beneath you, which feels so wonderfully solid and supportive, is in truth a vast lattice of nearly empty atoms, each one mostly open space, all of them held gently apart by invisible forces that never tire and never rest. You are not so much lying upon a solid thing as being cradled by countless quiet little fields of force, each one doing its small part to hold you up, to keep you from sinking through, to support your weight without your ever having to think about it. The whole world is performing this same invisible labor everywhere, all the time, holding itself together with a patience that has lasted since the beginning. Nothing is asking anything of you. The floor holds without effort. The walls stand without strain. The ground beneath the whole house is doing the same, and the planet beneath the ground, all of it woven from the same nearly empty, gently held matter. To rest, in a sense, is simply to trust this quiet work, to let the invisible forces do what they have always done, and to allow yourself to be held. For a long while, scientists believed that protons, neutrons, and electrons were the final pieces, the smallest building blocks, the bottom of the box. But when they began to push particles together at tremendous speeds and watch what happened, they discovered that the story went deeper still. Inside the protons and neutrons, those tiny marbles at the heart of the atom, there lived an entire small menagerie of even tinier and stranger things. It turns out that protons and neutrons are not smooth, solid spheres at all. Each one is built from smaller pieces called quarks. These quarks are peculiar little entities that almost never appear alone. They prefer company, gathering nearly always in groups of 3, and clinging to one another with a grip of extraordinary strength. What holds them so fiercely together is another kind of particle that behaves like a universal glue, fittingly named the gluon, after the very idea of glue, because its entire purpose is to bind. Without the gluons holding the quarks in place, the nucleus of every atom in existence would simply come undone in an instant. And nothing we know, no star, no planet, no quiet sleeper in a darkened room could hold its shape at all. While the quarks stay locked away at the center, the electrons drifting at the edges belong to a different family altogether. They are called leptons, and unlike the quarks, they do not seem to be built from anything smaller. As far as anyone has been able to tell, they are simply tiny points of pure presence, with no inner pieces to take apart. They are, in a sense, fundamental, irreducible, little full stops at the bottom of a sentence that cannot be divided further. But a collection of pieces, however small, is useless without rules to govern how they meet and how they speak to one another. That is the role of yet another group of particles, the ones that carry the forces of nature. It helps to imagine the matter particles, the quarks and the electrons, as players in some vast and silent game, and the force carriers as the balls they toss between them, the messages that let one piece feel another. The most familiar of all these messengers is the photon, the carrier of light and of the electric and magnetic forces. The photon is the reason light travels across a room, the reason a magnet tugs at a piece of iron, the reason your eyes can gather these very words. Other carriers, with quiet names like the W and the Z, handle more hidden tasks, including the subtle process that allows the stars to shine at all. All of these pieces, the quarks and the leptons, and the various carriers of force, together with the rules of how they meet, make up what physicists call the Standard Model. It is the closest thing we have to an instruction manual for the whole of ordinary matter, a description of how to build a star, a raindrop, a leaf, or the neurons quietly firing in a dreaming mind. And one of the most beautiful things about this manual is that it is the same everywhere. An electron here in this room, on this small planet, is exactly identical to an electron in a galaxy unfathomably far away. The universe does not keep different sets of bricks for different places. It builds everything, near and far, large and small, from the very same small handful of pieces. And yet, even with all these pieces named and sorted, a quiet question remains. If these particles are so impossibly small, where does their weight come from? Why should anything have mass at all? Why is it hard to push a heavy door? And why do some particles feel weighty while others, like the photon, weigh nothing whatsoever and drift forever at the speed of light? To answer that, we have to imagine an invisible ocean filling every corner of space. For many years, this puzzle troubled physicists. They could not see why certain particles carried weight while others carried none. The answer came from a British physicist named Peter Higgs, who in the 1960s proposed something quietly brilliant. He suggested that what we think of as empty space is not empty at all. The entire universe, he said, is filled with an unseen field, an invisible presence that touches everything, and which we now call the Higgs field. Picture it as a soft, silent fog that lies across all of space, gentle and everywhere at once. It fills the room around you. It fills the space between the stars. It fills even the tiny gaps between your own teeth and the deep emptiness inside every atom. Some particles move through this fog without noticing it at all. They glide through untouched, and so they have no weight and travel at the greatest speed nature allows, which is why light is weightless and swift. But other particles, the ones that make up the matter of your body, do feel the fog. As they move, the fog clings to them, slows them, gathers around them, and in that resistance they gain the property we call mass. Without this invisible field, the electrons and quarks would streak away at the speed of light, never slowing, never settling, never able to gather into atoms, into planets, into people. There would be no solid things at all, only an endless, brilliant rush. This leads to one of the most extraordinary ideas in all of science, and it is worth holding gently for a moment. At its deepest level, matter is not truly separate from energy. What we call mass is simply energy that has become so densely concentrated that it begins to take up space and to have weight. The great insight captured in Einstein's famous equation is exactly this, that mass and energy are two faces of a single thing, able to turn one into the other. If you could fully unravel even a single atom from your fingertip and release the energy bound up inside it, it would be enough to light a city for a very long time. The quiet matter of your hand is, in truth, a vast reservoir of energy held still and patient in the shape of you. This invisible field is not merely a clever idea on paper. In 2012, scientists working with an enormous machine buried beneath the border of two countries finally found its fingerprint. They detected a particle called the Higgs boson, which is something like the trembling of the field when you give it a sharp tap, proof that the fog is truly there. In that moment, we understood at last that matter itself is a kind of fortunate accident of energy. Everything you can see, from the warmth of the sun to the iron carried in your blood, is pure energy that has folded itself into complex and lasting forms, all because of these unseen fields woven through the emptiness. It is a curious and peaceful idea to rest within. The solid, familiar, quiet body lying here is, at its very foundation, energy that has slowed and gathered and settled into a shape. You are not separate from the great rush of energy that fills the cosmos. You are a small, calm eddy within it, a place where the universal current has wound itself patiently into the form of a living, breathing person. The same energy that blazes in the hearts of distant stars is the energy that, in another guise, holds your atoms together and warms your hands. There is no hard line between the stuff of stars and the stuff of you. It is all the same single thing, appearing in different costumes, flowing endlessly from one form into another, never created and never destroyed, only changing shape across the long ages. And tonight, for this little while, it has taken the shape of you, lying still and quiet, listening. But if you imagined that the quarks and electrons were the very bottom, the smallest things there could ever be, we must go down one final step into a place so tiny that the ordinary ideas of distance and even of time begin to fail. This is, in a sense, the basement of reality, the smallest scale that nature permits, and here we will finally meet the limit of how small a thing can be. We have been taking reality apart very gently, the way a child might open the back of an old clock to see what makes it move. We started with molecules, then opened the atom and found it nearly empty, then peered inside its tiny heart and discovered a hidden world of quarks and gluons and little points of pure presence. And so a natural question arises in the quiet. Can we keep dividing forever? Is space itself endlessly cuttable into ever smaller and smaller pieces with no end? Or is there a final, smallest tile beyond which there is simply nowhere smaller to go? To approach this, we travel back to the very beginning of the 20th century, to a thoughtful physicist named Max Planck. He discovered something that surprised everyone, including himself. Nature, it turned out, does not hand out its gifts in a smooth, continuous stream. It hands them out in small, complete packets, like coins of a fixed value. He called these packets quanta, and from that single idea grew an entire new way of understanding the world. There is a homely way to feel this. Imagine going to buy eggs. You can buy 6 eggs or a dozen or 15, but you cannot reasonably ask for 2.5 eggs or 5 1/3. Eggs come in whole units. Planck realized that the deepest levels of reality behave in something of the same way. Energy at the smallest scale comes in whole packets. You can have 1 or 2, but there is no such thing as half of the smallest possible amount. The world at bottom is grainy rather than smooth. This idea leads us toward a measurement so small that the mind simply gives up trying to picture it, called the Planck length. To get even the faintest sense of it, imagine an ordinary atom grown until it was as large as the entire visible universe. If an atom were that enormous, then on the same scale, the Planck length would be no bigger than a single tree standing on the surface of the earth. That is how unimaginably tiny it is. It is thought to be the smallest meaningful distance there can be, the point beyond which the very idea of length stops making sense. Below it, asking how far apart two things are becomes a question with no answer at all. This raises a quietly wonderful possibility. What if reality, at its very finest grain, is something like the screen of a phone or a television? When you hold a bright screen far away, you see a smooth, flowing image. But press your eye close, and the smoothness breaks into countless tiny squares of color, separate little pieces pretending to be a continuous picture. Planck's idea hints that the universe might be the same. Perhaps space is not an endlessly smooth fabric, soft as silk, but a kind of mosaic built from the tiniest indivisible pieces, stitched so finely that, from where we stand, it only looks seamless. At this smallest scale, space and time may cease to be the calm and steady stage we are used to, and become something restless and trembling that scientists have nicknamed quantum foam, a frothing, flickering sea where the orderly rules we trust begin to blur into one another. If you tried to go further still, below even the Planck length, the two great descriptions of nature, the one that governs gravity and the shape of space, and the one that governs the tiny quantum world, would clash and refuse to agree, and reality as we understand it would lose its footing entirely. So we let it rest there. The Planck length is the floor of the small. It is the frontier, the gentlest edge of the quantum world, the furthest down that we are able to go, and having reached it, we have nowhere left to descend. It is a strange comfort to know that the world has a bottom at all, that the dividing cannot go on forever, that there is a final, smallest grain beneath which the question simply stops. So much of life feels endless, bottomless, as though every layer hides another and another with no resting place. But here, at the very foundation of everything, reality offers us a floor. The cosmos is not an infinite regress of smaller and smaller worlds without end. It is built upon a smallest scale, a finest grain, a quiet foundation upon which everything larger is assembled. The atoms and the molecules and the mountains and the stars and the great walls of galaxies, all of it resting, in the end, upon this gentle, indivisible base, and from this floor, this firm and final bottom of the small, we now begin our long climb upward, knowing that everything we meet along the way, however vast, is built from these same smallest pieces, woven together with infinite patience into the immense. So now we turn around. We have stood at the very bottom of smallness, in the trembling foam at the base of reality, and from here the only direction is up and out. Let us leave the world of the tiny behind, very softly, and begin the long, slow journey toward the immense. We will open the windows now and look outside. The most natural place to begin our climb is close to home, in our own small corner of space, the solar system. When we see drawings of the planets in books and on classroom walls, they are usually crowded together, lined up neatly side by side, each one near its neighbor, as though you could stroll from one to the next on a quiet afternoon. It is a charming picture, and it is almost entirely a lie, told gently by the limits of a single page. The truth is that space is far, far emptier and far wider than any drawing can show. Begin with the moon, our closest companion in the sky, the silver light that has watched over every night of human history. It hangs a little less than 240,000 miles away. To us, that sounds enormous, and in human terms it is. No traveler on foot could ever cross it, and yet in the language of the cosmos, the moon is barely a single step from our door. Light, the swiftest thing there is, crosses that whole gulf in just over a single second. If you could ride a beam of light to the moon, you would arrive before you had finished drawing a breath. Now lift your gaze to the sun, and the scale begins to open up. We sit about 93 million miles from our star. That distance is so great that the sunlight warming your window this morning actually left the surface of the sun more than 8 minutes earlier. The light you see is always a little bit old. If the sun were somehow to go dark in an instant, we would not know for over 8 minutes. We would carry on in its warmth and brightness, unaware until the last of that final sunlight finished its long journey across the void and the sky quietly went dark. Centuries ago, a patient observer named Galileo turned a small telescope toward the heavens and began to understand that the sky was not a flat painted dome hung above us, but a place with real depth, real distance, real worlds. He watched tiny moons circling other planets, going round and round, and in doing so he gently overturned the comfortable old belief that everything revolved around us, that we sat at the center of all things. What he began to suspect we now hold as certain. The solar system, despite all its planets and moons, is almost entirely empty. To feel this emptiness, imagine setting a melon down in the middle of your room to stand for the sun. On that scale, the Earth would be no more than a tiny speck of dust, drifting many steps away across the floor. The other planets would be scattered far beyond the walls, out across your neighborhood, your town, with vast reaches of nothing in between. And the strangest thing about all that nothing is that it is not truly dead or still. The space between the planets is not a perfect void, but a thin, restless sea of particles and energy streaming out from the sun, racing through the dark. We live inside a kind of sheltered bubble, a small island of cool, solid matter floating in an ocean of fire and radiation. In fact, the gentle, solid sort of matter that you and I are made of is a great rarity in the cosmos. Far more of the ordinary matter out there exists as plasma, the searing, glowing stuff that fills the hearts of stars. The quiet, room temperature world we take for granted is the exception, not the rule. Let us drift outward for a moment, slowly in the imagination, and feel just how much space lies between the worlds. Leave the Earth behind, soft and blue, and float past the silver moon, already a step away. Continue outward past the small, fierce inner worlds, until you reach the great banded giant with its many moons, the one whose circling satellites first taught us that not everything turns around us. Out here the sun has shrunk to a bright coin, smaller and cooler, and the light takes far longer to arrive. Keep drifting past the ringed world hanging in the dark like a quiet ornament, past the pale blue-green planets far beyond, each one separated from the next not by a short hop, but by hundreds of millions of miles of nothing. And even when you have passed the very last of the planets, you are nowhere near the edge of the sun's gentle reach. Far, far beyond, in the deep cold, there drifts a vast and tenuous shell of icy fragments, the slow birthplace of comets, marking the true and distant border of our sun's domain. To cross even this, our own backyard, would take a spacecraft many thousands of years, and only then, having left the very outermost reaches of the solar system behind, would the real emptiness begin. For between our sun and the next nearest star lies a gulf so wide that everything we have just drifted past would seem, by comparison, like a single small house at the center of an enormous darkened field. It is a humbling and strangely peaceful thing to feel, this great roominess of home, this generous quiet surrounding our small island of warmth. We are held in a sheltered bubble, cradled by distance itself, and the very vastness that isolates us is also, in its way, what protects us. If it humbles us a little to know that sunlight takes 8 minutes to reach us, then we should brace ourselves gently, because we are about to leave the solar system behind entirely, and step into a region where miles become useless and the spaces between stars make our whole planetary system look like a tiny, cozy garden. When you plan a journey across your own country, miles or kilometers make perfect sense. We can picture the distance between two cities, or the stretch a plane flies between continents. But the moment we move beyond the Earth, the numbers begin to swell in ways that overwhelm the mind. Were we to measure the cosmos in miles, we would soon be writing strings of zeros so long that no one could read them aloud without losing their place. We need a far larger ruler, and the ruler we use is light itself. For most of history, people assumed that light simply was, instantly, everywhere it could reach, that the moment a candle was lit, the whole room received its glow in the same breath. But in 1676, a Danish astronomer named Ole Romer noticed something that quietly changed everything. While carefully watching the small moons of Jupiter slip into shadow and out again, he saw that the timing drifted, running a little late when the Earth was farther from Jupiter, as though the light carrying the news had farther to travel and needed more time to arrive. From this gentle delay, he drew a profound conclusion. Light is not instant. It has a speed, a definite pace, and it takes time to cross from one place to another. That speed is tremendous, almost beyond feeling. Light travels about 186,000 miles in a single second, and it is the absolute limit of the universe. Nothing can move faster. To make this enormous swiftness easier to work with, astronomers invented a unit called the light year, and it is worth pausing on a small but lovely point. Although the word year is in its name, a light year is not a measure of time at all. It is a measure of distance, the distance that light travels in one full year of journeying through empty space, and that distance is nearly 6 trillion miles. With this single elegant unit, we can say that a star lies 4 light years away, instead of writing out a number with 13 digits that no tongue could pronounce. But the most beautiful gift of measuring in light is something deeper than convenience. Because light takes time to reach us, the night sky becomes a kind of vast living archive of the past. When you look up at the stars, you are never seeing them as they are right now. You are seeing them as they were when their light first set out, sometimes years ago, sometimes centuries, sometimes longer still. Every second of distance between you and a star is a second of looking backward in time. A star 10 light years away shows you its face from a decade ago. You are gazing into history. To look up at night is to practice a gentle kind of archaeology, receiving ancient messages that have drifted patiently across the dark for ages, just to arrive tonight at your eyes. Let us linger here a moment, because it is a peaceful thought to hold. Imagine a single particle of light, one photon leaving the surface of a distant star. It is born in an instant, in a flash of energy somewhere far out in the dark, and from the very moment of its birth, it sets off across space at the only speed it knows, the greatest speed there is. It does not slow. It does not rest. It does not grow tired. It crosses emptiness so vast and so silent that in all its long travels, it may pass nothing at all for years upon years, simply drifting through the great calm between the stars. Whole human lives might begin and end while that single photon is still in flight. Empires might rise and fade. And then, after a journey of decades or centuries, after crossing distances that no living thing could ever hope to travel, that one small messenger arrives at the lens of an eye, or the surface of a telescope on a small blue world, and gives up everything it carried in a single quiet instant. The starlight you see tonight is the end of a journey that began long before you were born. Each point of light in the sky is a story that has already happened, reaching you only now, like a letter written long ago and delivered at last. There is something restful in knowing this. The night sky asks nothing of us but to look. It offers no urgency, no demand. It simply holds out the gathered past of the entire universe patiently for anyone who cares to lift their gaze. And whenever you do, you are catching the tail end of countless such journeys, each one begun in a different age, each one arriving together in the same quiet moment of your looking. Once we accept this gentle rule of the cosmos, we are ready to meet our nearest neighbor beyond the sun. If the sun were a single lamp glowing in the middle of an enormous dark field, then our nearest neighboring star would be another small lamp, set down impossibly far away across that field. That neighbor is called Proxima Centauri, and though we fondly call it our neighbor, it lies about 25 trillion miles from us. Billions upon billions of miles of empty silence stretch between. To grasp how isolated we truly are, consider that if we sent one of our swiftest spacecraft toward it, the journey would take tens of thousands of years. The space between the stars is an immense and patient solitude, a quiet gulf that keeps each star apart from all the others. The movies often show stars clustered close together, sweeping past one another, but the real sky is far lonelier and far more spacious than that. A Scottish astronomer named Robert Innes first noted Proxima Centauri in 1915, and since then, we have learned that it does not travel alone. It belongs to a small family of 3 suns together, known as the Alpha Centauri system. At the heart of that family are 2 stars, much like one another, slowly circle each other in a stately dance lasting about 80 years. While Proxima Centauri keeps to the outer edges, a smaller, quieter companion lingering at a great distance, like a shy younger sibling who prefers the shadows. Proxima itself is a red dwarf, a kind of star much smaller, cooler, and dimmer than our sun, so faint that no human eye could ever pick it out unaided. And yet its importance is enormous, because it is the first harbor in this great ocean of emptiness, the nearest other shore. What makes it more wonderful still is that it is not alone in the dark around it. With our instruments, we have found that a small world circles Proxima Centauri, a planet about the size of the Earth, orbiting at just the right distance for liquid water to be possible. It is a gentle reminder that, despite the unspeakable distances that hold us apart, we may not be a singular accident in the universe. Living there, though, would be no easy comfort. Proxima Centauri is a restless and temperamental star, given to sudden flares of radiation fierce enough to scour away the air from any world too close. This is the true character of the stellar neighborhood, a place where calm and danger live side by side, separated only by the thin shelter of distance. Each photon of light we catch from that star left its surface more than 4 years ago, a message in transit across an emptiness that both protects us and keeps us profoundly alone. Sit for a moment with the sheer quiet of that emptiness, because it is unlike any silence we know on Earth. Here, there is always something, a faint breeze, a distant sound, the hum of the living world. But out in the space between the stars, there is a stillness so complete that it is difficult even to imagine. No sound travels there, for there is almost nothing to carry it. No wind stirs. The nearest star is so far away that, were our sun to suddenly become the only light, traveling there would take far longer than the whole of recorded history many times over. And yet, this great solitude is not a frightening thing, once you understand it. The very distance that isolates each star is also what keeps them safe from one another, what gives every sun the room to live out its long life undisturbed. The emptiness is a kind of vast, gentle insulation, holding each star in its own quiet pocket of space, far from any neighbor that might trouble it. We tend to think of loneliness as something sorrowful, but the loneliness of the stars is closer to peace, an unbroken calm stretching across distances so wide that nothing can disturb it. And here on our small warm world, wrapped in our thin blanket of air, we are sheltered within that same great quiet, looking out at all those distant, patient lights. But the neighborhood does not end with a single nearby star. As we drift gently outward, we begin to notice something we might not have expected. The stars are not simply scattered at random across the dark, like grains tossed by a careless hand. Sometimes they gather into bright families, clusters of stars born together, which from our distant vantage may even blur into what looks like a single point of light. Although many stars, our own sun among them, seem to live solitary lives, the universe is in truth a place where stars love to be born in company. To understand where these clusters come from, we have to look at the great clouds of gas and dust that float in the spaces between the stars, the soft, dim, drifting structures we call nebulae. These are the true nurseries of the cosmos. Within them, gravity slowly draws the scattered material inward, gathering it more and more tightly until, in the densest knots, the gas grows so hot and so compressed that a new star kindles into life. One of the most beloved examples is the great nebula in the constellation of Orion, an enormous glowing region where hundreds of stars are being born even now, in this very moment far away in the dark. In the 1700s, a French astronomer named Charles Messier became quietly famous for cataloging these soft, blurry objects in the sky, though he never set out to do so. His true passion was hunting comets, those rare visitors trailing their tails across the night. The trouble was that these dim, fuzzy patches of light kept fooling him, looking just enough like distant comets to send his heart racing before he realized his mistake. So, partly out of frustration, he began to write down their positions, making a list of all the things that were not comets, so that he would not be fooled by the same blur twice. Over time, that practical little list of distractions grew into one of the most treasured catalogs in all of astronomy, a gentle map of the soft treasures of the sky, and it still bears his name today. One of the loveliest entries on his list is a cluster known to many simply as the Seven Sisters, a small, glittering knot of stars that has been admired by countless cultures across the ages. It is what astronomers call an open cluster, a loose gathering of young, hot, blue-white stars, and if you look at them through a telescope, you can still see a faint bluish haze drifting around them, the leftover veil of the very nebula that gave them birth. They lie a little over 400 light-years away, which sounds impossibly far, and yet on the scale of our galaxy, they are practically just around the corner. These clusters are precious to science because they serve as natural laboratories of time. Since all the stars in a single cluster were born together, at roughly the same moment, we can watch how differently they age. The biggest, brightest stars burn through their fuel furiously and live only a few million years, brief and brilliant, while the smaller, gentler stars in the very same group will go on glowing softly for billions of years more. These young stars do not sit quietly. They pour out fierce radiation that pushes the surrounding gas away, sweeping their neighborhood clear like a slow cosmic wind, and that pressure can sculpt the remaining clouds into shapes like towering pillars and ridges of glowing dust. In time, as they all circle the galaxy together, the gravity of passing objects gently tugs them apart until each star drifts off to follow its own lonely path, just as our own sun did long ago, parting from the brothers and sisters with which it was born. Almost every star you can see on a clear night was once part of a nursery like this. To understand these gathering places is to see the universe as a patient, endless cycle in which the ashes of dead stars become the seeds of new ones. There is a deep gentleness in this cycle. Once you let yourself feel its shape, nothing in the cosmos is ever truly wasted, and nothing is ever truly final. When a great star comes to the end of its long life and scatters its substance across the dark, that substance does not simply vanish into nothing. It drifts and cools and gathers, and in time it becomes the raw material for new stars, new worlds, perhaps new life. The same atoms are used again and again, passed down through generations after generation of stars across billions of years, like a single thread woven through an endless tapestry. The carbon in a leaf, the iron in a drop of blood, the calcium in a sleeping child's bones, all of it has belonged to other things before, and will belong to other things again, long after we are gone. There is no ending in this picture, only transformation, only the quiet handing on of matter from one form to the next. The universe does not hoard, and it does not waste. It simply keeps creating patiently, out of what has come before, turning endings softly into beginnings, over and over, for as long as time itself shall last. Yet even though the stars are held apart by such tremendous distances, our eyes have always drawn pictures among them, shapes that have guided people for thousands of years. For as long as there have been human beings to look upward, we have searched the scattered lights for order, connecting one point to another in our minds, imagining hunters and animals and gods, as though sketching figures on a great dark page to help us find our way. These imagined figures are what we call the constellations, and they are, in their own way, one of the loveliest illusions in all of nature. We tend to feel that the stars of a constellation truly belong together, gathered in one place out in space, but the truth is that they are often separated by gulfs we can scarcely imagine. The ancient astronomer Ptolemy was among those who helped fix this great map of figures in the human mind, cataloging many of the constellations we still use to mark the turning of the seasons. For him and for the ancients, the sky was a single smooth sphere, a dome upon which all the stars were fixed at the same distance from the earth. We now know that this comforting image is not real. If you could journey out into space and look back at those same constellations from a different angle, every familiar figure would fall apart, the stars scattering in all directions, because they were never truly together at all. Consider the great figure of Orion the Hunter, one of the most recognizable shapes in the sky. On one shoulder burns a vast reddish star, and at one foot shines a brilliant blue-white one. From your window, the two appear to hang at the very same depth, side by side on the same dark dome. But one of them lies many times farther away than the other, hundreds of light years more distant, its light far older by the time it reaches us. They are not neighbors, they are not companions. They simply happen to fall along the same line of sight from where we stand, like two lamps, one near and one far, that appear to touch only because of where you are standing. Even the very brightest star in the entire night sky, which seems to keep company with Orion, is in fact at a completely different distance, far closer than the Hunter's more distant stars, but blazing so brightly that it tricks the eye into placing it alongside them. The night sky, then, is a kind of beautiful coincidence, a flat picture made of lights set at wildly different depths, arranged by chance into the figures we have loved for so long. It teaches us gently that the heavens have a true depth we cannot feel with our eyes alone. Our vision is a limited translator, reading only a thin sliver of the energy that fills space. The constellations remain wonderful tools for finding our way and for marking the seasons, but they are, in the end, drawings made of distances we cannot see. It is worth resting for a moment on how old this habit of ours truly is. Long before there were cities, before there was writing, before any of the names we now use for the stars, there were people lying back upon the cool ground at the end of a long day, looking up into the same dark sky that hangs above you now. They did not know what the stars were. They did not know the distances or the light years or the slow turning of the galaxy, but they watched night after night, season after season, and they noticed that the patterns moved in faithful rhythms, that certain stars rose when the rains came, that others returned when it was time to plant or to travel. Across every corner of the world in every age, human beings looked up and saw the same scattered lights and gave them different names, wove them into different stories, and used them to find their way home across dark seas and trackless deserts. A sailor far from any shore could look up and know which way was north. A traveler crossing the night could read the slow wheel of the sky and know how much of the darkness remained before dawn. Whole calendars, whole harvests, whole journeys depended on these quiet lights. The sky was the first clock, the first map, the first great book that humanity ever learned to read, and it asked for nothing in return but attention. There is a deep and gentle continuity in this. The very same stars that guided people across the oceans thousands of years ago are shining down upon you tonight, scarcely changed, patient as ever. The light has traveled a little farther, the figures have shifted by the smallest fraction, but in all the ways that matter, you are looking at the same sky your most distant ancestors gazed upon, and feeling, perhaps, a little of the same quiet wonder they felt. And with this new way of looking, we are ready to step beyond our little stellar neighborhood altogether and begin the journey toward the truly great. As we drift away from the nearby stars and leave the familiar constellations behind, we slowly come to understand that all the stars we can see on a single clear night are only a tiny fleck in an enormous structure, the true home of our sun, the galaxy we call the Milky Way. If you could somehow rise above it and look back from far outside, you would see a majestic spiral wheeling slowly in the dark, its great arms curving gracefully outward from a glowing heart that gleams like a jewel set in the night. A pioneering astronomer named William Herschel, the same patient observer who first discovered the warmth of invisible infrared light, was among the first to try to give shape to this galactic home. He set about counting stars in different patches of the sky, trying to map where our island of stars began and ended. He guessed mistakenly that the sun sat near the center, but his careful work was the first real step toward a profound realization that we do not float in a chaotic jumble, but live within a vast and ordered architecture, a structure with a true shape that can be studied and understood. Our galaxy stretches about 100,000 light years from edge to edge, so that the mind does not stumble trying to imagine that in miles, it is enough to say that crossing it at the speed of light, the fastest pace in all of nature, would take 1,000 centuries, 100,000 years of travel at the speed of light, simply to pass from one side of our home to the other. And within all that immensity, we hold no place of honor at the center. We live in truth in the quiet galactic suburbs, out along one of the smaller spiral arms, roughly halfway between the busy, brilliant core and the dim outer edge, in a calm and unremarkable corner far from the crowded heart of things. The center of the Milky Way is a dense and crowded region that we cannot see directly in ordinary light, because vast clouds of cosmic dust hang between us and it, drawing a thick curtain across our view. But by listening to the sky in other ways, gathering the radio waves that pass through the dust unhindered, we have learned that powerful and dramatic things unfold at the heart of our galaxy. There, stars race at tremendous speeds around an enormous, hidden center of gravity that rules over everything. Meanwhile, out in our peaceful corner, the sun carries us in a slow and stately circle around that distant center, completing a single great orbit only once every 230 million years. drawing all of us along on a journey we have only just begun to understand. Let that span of time settle gently for a moment, because it is almost beyond feeling. A single trip of the sun around the heart of the galaxy takes 230 million years. The last time our sun was where it is now, in this same place along its long galactic path, farthest were just beginning to walk the young Earth. Whole ages of life have risen and flourished and vanished in the time it takes our star to circle home just once. Mountains have lifted up and worn away. Oceans have opened and closed. Countless generations of living things have been born and have died. The entire sweep of human history occupying less than the faintest sliver of a single one of these great cosmic years. And through all of it, quietly, without our ever feeling the motion, we have been sailing through the galaxy at a tremendous speed, carried along on the slow turning of the spiral, bound for a place our star last visited before our kind existed. We are always traveling, even now, even as you lie perfectly still. The whole great wheel is turning beneath us, patient and unhurried, and we are simply along for the ride. We live on a small planet, around an ordinary star surrounded by hundreds of billions of other suns, and as vast as the Milky Way feels, it is only one galaxy among countless billions drifting through the dark. For a long stretch of history, people believed that the universe ended just about where the stars they could see came to an end. It seemed a reasonable assumption, because whenever astronomers measured the distances to the stars, they kept finding them tucked within a certain limit, as though confined inside a single island of light, with darkness and nothing beyond. But a few faint objects refused to obey this comfortable rule. Some of the soft, blurry patches in Messier's catalog gave strange and slippery answers when astronomers tried to measure how far away they were, sometimes seeming close, sometimes impossibly distant, as though they lay outside the island altogether. Most assumed it was simply a mistake in the measuring. One thoughtful mind, however, was not so sure. A German philosopher named Immanuel Kant, in the middle of the 1700s, put forward a bold and quiet idea in a book about the nature of the heavens. Those nebulous patches that seemed too far away, he proposed, really were that far away. And more than that, they were not clouds of gas at all, but entire other island universes, other galaxies, much like our own, each a vast city of stars in its own right. The scholars of his day mostly set the idea aside, in part because there was no way to test it. Kant was a thinker ahead of his instruments, limited by the telescopes of his time, and so his beautiful guess had to wait. It waited almost 2 centuries. At last, in 1929, an astronomer named Edwin Hubble took the most powerful telescope of his age, turned it upon those mysterious blurs, and uncovered the truth. Many of those faint smudges of light were not nearby clouds at all. They were whole galaxies lying at distances once thought impossible. Kant had been right all along. With this discovery, the universe suddenly grew vastly larger, and we came to understand that our own galaxy belongs to an organized gathering of galaxies that we call the local group, our immediate neighborhood in the cosmos, a collection of more than 50 galaxies bound softly together by gravity. It is worth noticing how often this has happened in our long effort to understand the heavens. Again and again, just when we felt certain we had found the edge of things, the universe quietly revealed that it was far larger than we had dared to imagine. We once believed the Earth was the center of everything and learned that it was not. We believed the sun sat at the heart of the cosmos and learned that it, too, was off in a quiet corner. We believed our galaxy was the whole of creation and discovered it was one of countless billions. Each time, the universe gently overturned our smallness of vision, and each time, far from diminishing us, it made the world more wondrous. There is a humility in this story that feels less like defeat and more like an opening, like a series of doors swinging wide, one after another, onto ever larger rooms. We have learned to hold our certainties lightly, knowing that the cosmos almost always turns out to be grander than we supposed. And perhaps there are doors still ahead of us, larger rooms not yet entered, waiting patiently for minds not yet born. The great companion of our local group is Andromeda, a magnificent spiral galaxy even more massive than our own Milky Way. It lies about 2.5 million light-years away, a number that gently defies all ordinary sense. To feel the weight of it, consider this. The light now arriving in our telescopes from Andromeda began its long journey across the dark before the first human beings ever walked upon Earth. When you look at that faint smudge of light, you are seeing the galaxy not as it is, but as it was in a time before our species existed. Around these two great spirals drift smaller galaxies, gentle companions that orbit the Milky Way the way the moon orbits our world, like satellites circling slowly in the dark. Every time we map the local group, we are witnessing a choreography that has taken unimaginable ages to perfect, a slow dance of encounters and mergers guided by laws that play out across scales far beyond anything in our daily lives. This dance, gentle as it is, never stops. Even now, our Milky Way and the great spiral of Andromeda are slowly drifting toward one another across the dark, drawn together by gravity's patient pull. Billions of years from now, far beyond any human time, the two galaxies will meet and slowly merge, swirling together over hundreds of millions of years into a single new galaxy. And yet, despite how dramatic that may sound, it would be a remarkably peaceful event to witness. Galaxies are so vast and so empty, with such enormous distances between their stars, that when two of them pass through one another, almost no stars actually collide. They simply glide past each other, like two great clouds of light drifting and blending in the dark, rearranging themselves over ages too long to picture. No one will be hurt, nothing will be shattered. It is less a crash than a slow and graceful joining, two grand spirals folding together into something new. There is a quiet reassurance in knowing that even the great collisions of the cosmos unfold this gently, this patiently, with so much room to spare that the stars themselves pass by like ships in a wide and welcoming harbor. With this picture in mind, we are ready to leave even our immediate galactic family behind, and to peer at the structures that truly dominate the map of the cosmos. As we travel farther from the Milky Way, the distances grow so immense that we need an entirely new way of thinking about how reality is arranged. Galaxies do not simply float about wherever they please, like lost ships scattered across a shoreless sea. Just as we gather ourselves into villages and cities and nations, the universe too has its own great hierarchy, its own way of organizing matter on the grandest scales. If the local group, the small family that holds our Milky Way, is our neighborhood, then the next level up is what astronomers call a galaxy cluster. A cluster, as the name suggests, is an enormous congregation of galaxies, hundreds or even thousands of them, held together by the invisible bond of gravity. In the 1930s, an astronomer with a famously sharp tongue and a brilliant, restless mind named Fritz Zwicky was studying one such cluster when he noticed that something did not add up. The galaxies within it were moving far too quickly. By all his calculations at those speeds, they should have flung themselves apart and scattered into the dark billions of years ago. And yet there they remained, held together by something he could not see. Zwicky reasoned that there must be some hidden mass, some unseen substance exerting a powerful gravitational pull, quietly holding the whole cluster in place. He called it dark matter, and he became one of the first to suspect a startling truth, that the universe we can see is only a small fraction of all that truly exists. For a long while, the idea was largely ignored. But years later, an astronomer named Vera Rubin, working with a colleague named Kent Ford, confirmed this invisible architecture beyond doubt. According to the familiar laws of motion, stars at the outer edges of a galaxy should drift more slowly than those near the center, just as the outer planets circle the sun more slowly than the inner ones. Instead, Rubin found that the stars at the far edges of galaxies were racing along just as quickly as those near the heart. The visible matter, all the stars and gas and dust, was nowhere near enough to explain it. Something unseen had to be there, supplying the extra pull. Her careful work showed that galaxies hold many times more invisible mass than visible mass. Without this unseen web, the universe would be a thin, scattered fog. We now understand that dark matter is the true scaffolding of the cosmos, the hidden framework upon which everything that shines is gently hung. In our own region of space, the cluster that holds sway is the Virgo cluster, an immense galactic city containing as many as 2,000 galaxies, exerting a pull so strong that even our own Milky Way is slowly drifting toward. But the hierarchy does not stop at clusters. Clusters themselves gather into still larger structures called superclusters. Our own large-scale home is the Virgo supercluster, a structure spanning more than 100 million light-years across. At this scale, entire galaxies become little more than points of light, gathered along the strands and knots of a vast cosmic network, and ours is merely one among a multitude. And even this, as enormous as it is far from the largest thing there is. It can take the breath away, this endless climbing of scales, each one dwarfing the last so completely that the mind can scarcely keep pace. Just when a galaxy seems impossibly large, it becomes a single member of a cluster. Just when the cluster seems beyond imagining, it becomes a speck within a supercluster, and the supercluster, in turn, is only one knot in a web that spans the visible universe. There is no shame and no sadness in feeling small before all of this. To feel small in this way is not to feel worthless. It is something closer to the quiet awe a person feels standing at the foot of a great mountain, or at the edge of a vast and shining sea. The smallness is part of the beauty. We are tiny, yes, almost unimaginably so, and yet we belong to the whole of it, connected by gravity and light and shared substance to every distant point of light. To be a small part of something this immense is not a burden. It is a kind of belonging, gentle and complete. The comfort of knowing that we are held within a structure far greater and far older than ourselves, and that our small place within it is no less real and no less wondrous for being small. Sometimes, what teaches us most about the shape of the universe is not where the light gathers, but where it is utterly absent. Among all the clusters and superclusters, there are also strangely, profoundly empty places, regions where there is almost nothing at all. One of these is a vast emptiness, sometimes affectionately called the Great Nothing. If the universe were a great Swiss cheese riddled with holes, this would be among the largest and deepest holes you could find anywhere near us. This immense void was discovered in 1981 by an American astronomer named Robert Kirshner and his team. Before they found it, no one had imagined that such enormous spaces could exist with scarcely a single galaxy in sight. This bubble of darkness measures around 330 million light-years across. It is so vast that you could place our entire Virgo supercluster inside it and still have a great deal of room to spare. If you were somehow set down at the very center of this emptiness, you could look in every direction and see nothing whatsoever with your unaided eyes. No points of light, no distant galaxies, no landmarks of any kind. Only an endless, seamless blackness reaching out forever. An astronomer once captured this loneliness with a memorable thought. If our own Milky Way had happened to form at the center of such a void, he said, we might not have discovered that other galaxies existed at all until well into the modern age, because the nearest lights would have been so impossibly far away that our older telescopes could never have caught them. We would have lived upon an island of light, ringed by an ocean of nothing stretching billions upon billions of miles in every direction, and we might have been entirely convinced that we were the only thing in all the universe, alone and complete unto ourselves. But how does so vast an emptiness come to be? The answer, once again, is gravity working with infinite patience. Imagine that the early universe was something like a damp sponge, very slightly uneven, with some places holding a little more matter than others. Those slightly richer regions began, ever so slowly, to draw their neighbors inward, gathering galaxies toward themselves like soft magnets. Over billions of years, the dense places grew steadily richer in galaxies, while the thinner places were drained, emptied, gradually swept clean as their matter drifted away toward the gathering crowds. The great void is simply this process carried to its furthest extreme, a place where matter lost the long, slow tug of war and was drawn away to the edges by the pull of distant superclusters. Despite its name, it is not perfectly empty. A scattered handful of lonely galaxies do drift within it, but they are so isolated, so far from any companion, that they resemble castaways adrift in an endless dark sea. These rare, solitary galaxies are precious to us because they show how matter behaves when it grows up almost entirely alone, with no neighbors near enough to disturb it. It is worth dwelling, just for a little while, on the strange and lovely shape that all of this takes when we step back far enough to see it whole. If you could gather up every galaxy in the observable universe and watch how they are arranged, you would not find them spread evenly, like sugar scattered smoothly across a table. Instead, you would see something that looks almost alive. The galaxies gather along immense glowing threads, vast filaments stretching across hundreds of millions of light years, and where those threads cross, they knot together into brilliant clusters and superclusters, the great cities of the cosmos. And between the threads lie the enormous dark hollows, the voids, the quiet empty bubbles where almost nothing dwells at all. Seen from far enough away, the universe resembles a great web, or a sponge, or the delicate branching of nerve cells in a living brain, or the soft tracery of foam upon a wave. It is the same pattern, repeated on a scale almost too large to imagine, and it was shaped over billions of years by nothing more than gravity, working patiently upon the faint unevenness left over from the universe's earliest moments, and holding this whole vast web together, threaded invisibly through every filament and knot, is that hidden scaffolding of dark matter, the unseen framework upon which all the visible light is hung. We cannot see it, we cannot touch it, we do not yet truly know what it is. And yet, without it, the galaxies would never have gathered, the stars would never have formed, and there would be no one here to wonder about any of it. There is something quietly comforting in this, in knowing that the brilliant things we can see are held in place by gentle, invisible hands we cannot. The universe is far more structured, far more woven together than the empty darkness of a night sky might suggest. We are not floating in chaos. We are resting within an architecture of breathtaking order, one strand of an immense and patient web. This cosmic desert, though, is only one thread in the larger fabric that surrounds us. Having gazed into the deepest emptiness, let us now turn back toward the structure that shelters us, the one that gives our small galaxy its place and its direction upon the great map. Until very recently, astronomers believed that the Virgo supercluster marked the upper limit of our belonging, a kind of final boundary beyond which we were no longer part of anything in particular. But in the year 2014, a team of astronomers led by Brent Tully and Helene Courtois changed that picture entirely and redrew our address in the universe. By patiently mapping the individual motions of galaxies, tracing not just where each one sits, but which way it is drifting, they discovered that all galaxies of our local group, our own among them, together with the nearby superclusters such as Virgo, are all sliding together within an even greater structure. They gave it a Hawaiian name meaning immeasurable heaven, a name that feels exactly right for something so vast it can scarcely be held in the mind. It is called Laniakea, and what makes Laniakea so different from a simple cluster is that it is not merely a crowd of galaxies that happen to lie near one another by chance. It is a structure defined by motion, a great realm in which all the galaxies are flowing together as one, drawn along the same invisible currents toward the same distant destination. To feel how it works, imagine the slopes of a great mountain range after rain. If a single drop of water falls on one side of a ridge, it will trickle down and join one particular river, finding its way at last to one particular sea. But if that same drop had fallen just a little farther over, on the other side of the ridge, it would have flowed into an entirely different river, toward an entirely different sea. Laniakea is our cosmic watershed. It is the great territory across which some 100,000 galaxies are all gently slipping down invisible slopes toward a shared destination, every one of them following the same long, slow current. Its dimensions are staggering. Laniakea spans about 520 million light-years, and on this enormous map we hold no central place at all. Our Milky Way rests near one of the far outer edges, like a small cottage standing at the coast of an immense continent, far from the great galactic cities at the heart of things. Everything we once thought immense, even the mighty Virgo cluster, turns out to be only a small branch of this seemingly endless galactic tree. The most wonderful thing about Laniakea is that it lets us glimpse the true border of our home. Right beside us lies another great supercluster, but the galaxies there are flowing in the opposite direction, sliding away down a different slope toward a different basin. That dividing line, where gravity decides which way a galaxy will fall, is the real edge of our cosmic country. Seen all at once, Laniakea has an astonishing form, a branching web-like architecture that, through a telescope, looks uncannily like a network of nerve cells or the fine roots of a plant reaching out through the soil in search of water in the dark. Laniakea is our last true frontier. Beyond it, we will find structures even greater, but ones to which we no longer belong. Yet before we journey onward, there is a question worth pausing on here in the quiet. We said that all the galaxies of Laniakea are moving together, flowing in harmony. But moving where? Toward what? On Earth, water always finds its way down to the sea, pulled by gravity along the gentlest available path. Something very similar is happening in space. The planets are held in their courses by the gravity of the sun. The stars are held within the arms of the Milky Way by the pull of the galactic center and its hidden dark matter. But what holds Laniakea together, and toward what is everything sliding? Long before Laniakea itself was mapped, astronomers had already noticed that our Milky Way, along with thousands of other galaxies, was not drifting aimlessly at all. We are being drawn. We are moving at well over 1,000,000 miles an hour toward a particular point in space, a place that has long remained one of the great mysteries of cosmology. This point of intense gravitational concentration, hidden deep within Laniakea, is known as the Great Attractor. And the curious trouble is that the Great Attractor is, in a sense, playing hide-and-seek with us. We know it is out there, we can feel its pull, but we cannot easily see it, because it lies in a region of the sky that astronomers call the zone of avoidance. The thick dust and crowded stars at the center of our own Milky Way hang directly between us and that direction, drawing a heavy curtain across our view. It is rather like trying to peer through a brick wall with nothing but your eyes, knowing that something enormous lies just on the other side. There is something almost soothing about this, about the fact that even now, with all our instruments and all our learning, the universe still keeps a few of its largest secrets gently hidden from us. We can feel the pull of the Great Attractor without quite being able to see its face. We can know it is there, vast and patient, shaping the motion of our entire neighborhood, and yet still have to wait and wonder and slowly piece together its nature through indirect signs. The cosmos has not handed us all its answers at once. It reveals itself slowly, a little at a time, leaving plenty still veiled in the dark for those who come after us to discover. And perhaps that is exactly as it should be. A universe with no mysteries left would be a strangely quiet place. The not knowing is part of the wonder. It is the open door that keeps us looking up, keeps us curious, keeps the long conversation going. There is no need to solve it tonight. The mystery will keep, patient as the dust that hides it, and it will still be there, waiting and wonderful, long after you have drifted off to sleep. It was an American astronomer named Alan Dressler, working in the 1980s with a group of colleagues, sometimes nicknamed the Seven Samurai, who helped confirm that this gravitational anomaly was real, and that it was powerful enough to shape the destiny of an immense region of the cosmos. We now understand that the Great Attractor is not a single object, not some colossal black hole or one impossibly heavy star. It is something far grander. It is the gravitational heart of Laniakea itself, a region where clusters of galaxies are gathered so densely that their combined weight equals tens of thousands of galaxies like our own. There, gravity is so overwhelming that it bends the very fabric of space across our entire neighborhood, compelling every galaxy within a vast radius to surrender to its slow and patient pull. And yet there is something strange and almost wistful about this great journey. Though we are being drawn toward the Great Attractor with tremendous force, the most careful calculation suggests that we will never actually arrive. How can this be? How can something pull us so hard for so long and still never bring us home? The answer is that there is another force at work, an unseen power doing exactly the opposite of gravity. While the Great Attractor labors to gather everything together into one vast embrace, this other force is stretching space itself, pushing the far horizons ever farther away, faster than we can ever travel toward them. The shape of everything we see is decided by this quiet, ceaseless struggle, gravity forever trying to draw things together, and the expansion of the universe forever trying to pull them apart. We are, in a sense, running toward a destination on a path that is itself stretching out beneath our feet, lengthening faster than we can cross it. To understand why this journey may never end, we have to speak of that mysterious stretching force, the one that is slowly winning the long contest and making the universe larger with every passing moment. This brings us to a discovery that left astronomers quietly astonished near the close of the 1990s. Until that moment, nearly everyone assumed that the expansion of the universe must be slowing down. It seemed only sensible if every galaxy carries mass, and all that mass tugs upon all the rest through gravity. Then surely that gathering pull should act as a gentle brake, gradually easing the growth of the cosmos, perhaps one day halting it altogether. But in 1998, a team of researchers, led by an astronomer named Adam Riess, found that the truth was precisely the opposite of what everyone expected. They had been watching a particular kind of stellar explosion, a special sort of supernova so consistent in its brightness that it can serve as a reliable beacon, a standard candle, glowing across enormous distances with a known and trustworthy light. By measuring how quickly these beacons were receding from us, they noticed something that no one had foreseen. The most distant galaxies were not merely drifting away. They were drawing apart faster and faster, accelerating, as though some force were pressing the whole cosmos outward with growing strength. It was as if you tossed a ball gently into the air and, instead of slowing and falling back into your hand, it suddenly surged upward, climbing ever faster into the sky. This happens because space is not a fixed and empty stage upon which galaxies move. Space itself is a real thing, and it can stretch. Imagine a loaf of raisin bread slowly baking in an oven. As the dough rises and swells, the raisins all drift apart from one another, not because any single raisin is crawling through the dough under its own power, but because the dough between them is steadily growing. The galaxies are like those raisins, and the expanding space is like the rising dough. They are being carried apart by the swellings of the space between them, and that swelling is not only continuing but quickening. For a time, no one could say what this mysterious outward pressing force might be, and so, for want of a better name, they called it dark energy. We still do not truly know what it is, but we know it is everywhere, woven evenly through all of space, and we know it makes up the great majority of everything that exists, far more than all the stars and galaxies and dark matter combined. It behaves like a faint pressure filling the void, gently and relentlessly urging space to expand. To put it simply, dark energy is the reason the great cosmic path stretches out faster than the galaxies can ever run along it. This means that on the very largest scales, the pull of the great attractor is ultimately losing its long battle. With every passing second, this expansion opens up millions of miles of new space between the distant superclusters of galaxies. And this carries a consequence that is, in its way, quietly melancholy. There will come a day unimaginably far in the future when many of the galaxies we can see tonight through our telescopes will have drifted so far away that their light will no longer be able to reach us at all. The space between us and them will be stretching faster than light itself can cross it. And so, one by one, those distant lights will slip beyond our reach and vanish from the sky forever. We are, it seems, living in a privileged moment, an age when the universe is still full of visible neighbors, before the slow tide of expansion carries them out of sight. Happily, this fate will not befall our nearest galaxies, the ones bound to us closely enough by gravity. Those companions will remain with us, gathered near, even as the farthest reaches drift away into the dark. There is a tender quality to living in this particular moment of cosmic history, and it is worth holding gently. We have arrived at a time when the universe is still young enough, still full enough, that the night sky brims with distant light. We can look out and see galaxies upon galaxies, the faint glow of structures unimaginably far away, the lingering afterglow of the universe's first ages. Beings who come long after us in an age so distant that the numbers lose all meaning may look up into a sky grown quieter, with the most far-flung galaxies having slipped forever beyond their sight. They would have to take it on faith, perhaps, that the universe was once so crowded with light. But we are here now in the bright and generous middle of things, when so much is still visible, still reachable by the patient eye. It is a kind of gift, this timing, this window of fullness, and there is no sadness in it tonight. The galaxies that are bound to us will stay. The light that fills our sky is here for ages yet to come, and we are fortunate, beyond any measuring, simply to be looking up during the long, bright afternoon of the cosmos, while there is still so very much to see. Now, having understood the force that pulls everything apart, let us return to the greatest structures in the universe and ask whether anything lies beyond Laniakea at all. The answer is yes. Laniakea, vast as it is not the final boundary of anything. It is simply one great region within a still larger pattern, the immense cosmic web that threads through all of space, a network of glowing filaments and dark, empty voids spread across the whole observable universe. Beyond Laniakea, the universe carries on, with structures larger and denser still. One of these is the Shapley supercluster, among the most massive concentrations of galaxies we have ever found. Recent studies suggest that its sphere of gravitational influence reaches across more than 1 billion light-years, and that it holds a volume many times greater than all of Laniakea, gathering within it millions of galaxies. It exerts a powerful pull upon Laniakea and upon its neighboring regions, a distant giant tugging gently at our entire cosmic country from far across the dark. And yet, remarkably, even Shapley does not hold the record for the largest thing we know. In recent years, astronomers discovered something so vast that it makes even Laniakea seem like a single speck of dust. They gave it a name borrowed from an ancient counting system, a name that refers to the knotted cords once used by an old civilization to keep their records and remember their stories, an apt name for a structure that itself looks like threads and knots woven across the heavens. A young astronomer who had already startled the scientific world by finding other enormous formations resembling great arcs and rings of light spun across the dark, was among those who helped identify it. This structure is a long chain of galactic filaments, stretching across more than 1 billion light-years. To put that into ordinary distance is almost meaningless. The figure runs into tens of thousands of trillions of miles, a distance so immense that light, hurrying at its greatest possible speed, would need a sizable fraction of the entire age of the universe simply to travel from one end of it to the other. What makes this newly found giant such a delightful puzzle for cosmologists is that, according to our current understanding, a structure like it should not really exist. There is a quiet expectation in cosmology, sometimes called the cosmological principle, which holds that on a large enough scale, the universe ought to look more or less the same everywhere, smooth and evenly mixed, like a well-stirred soup. But this enormous chain of galaxies is like finding a single huge knotted lump in the middle of that soup, far too organized, far too vast to have formed so neatly in the time available, following the laws of physics as we currently understand them. It is built of galaxies and clusters that seem to be strung together along great filaments of dark matter, and it stretches across a meaningful portion of the visible sky. To see something so large forces us to wonder, gently, Whether the early universe carried more powerful seeds of structure than we ever supposed, or whether gravity works in ways we have not yet fully understood. This great new giant has claimed its place as one of the largest things on our map of the cosmos, reminding us that the universe seems to prefer long, elongated, intricate forms over simple round clouds of galaxies, and yet, immense as it is, it still does not hold the ultimate record. There is one structure larger still, a wall of light stretched across the cosmic horizon, marking the very edge of what human beings have so far been able to map. All through this long journey, we have been climbing, step by gentle step, up a ladder of sizes that seems to have no top, and now we arrive at the very highest rung we have yet found, a thing of such absurd and overwhelming proportions that many scientists still quietly shake their heads, unsure how something so large could ever have come to be. It is called the Great Wall of Hercules Corona Borealis, and it is the largest, most massive object that human beings have ever detected in the entire history of looking at the sky. This structure was not found by gazing at individual galaxies through an ordinary telescope, because it is far too immense to fit within any single picture. No photograph could ever contain it. Its existence was revealed instead through a different kind of patient detective work. In the year 2013, a Hungarian astronomer named István Horváth, working with his team, was mapping the locations of gamma-ray bursts, the most powerful flashes of light in all the universe, brilliant beacons unleashed by the deaths of giant stars and the collisions of black holes. Horváth noticed that in one particular region of the sky, between the constellations of Hercules and the Corona Borealis, the Northern Crown, there was a concentration of these flashes that made no statistical sense at all. It was rather like standing in a single street during a thunderstorm and seeing thousands of lightning bolts strike there, and almost nowhere else. By connecting those scattered points of light, by drawing lines between the flashes, they uncovered a single structure stretching across an almost unthinkable distance, around 10 billion light-years from end to end. To even attempt that distance in ordinary terms is to enter the realm of pure abstraction, a number with so many trailing zeros that it loses all meaning. Perhaps it is gentler to say it this way. This single wall of galaxies takes up nearly a tenth of the entire observable universe. If you could somehow see it glowing in the night sky, it would sprawl across a vast stretch of the heavens, reaching far beyond anything your eyes could take in at a single glance, a luminous ribbon draped across the whole horizon. The deep trouble with this great wall is that it breaks the rules of the game, just as the long knotted chain of filaments did, only more so. There is a theoretical limit to how large any cosmic structure should be able to grow, because the universe simply has not existed long enough since its beginning for gravity to gather so much matter into one place. The mathematics suggests nothing should stretch much beyond a little over 1 billion light-years, and yet this wall is many times larger than that supposed limit. It is rather like wandering into a quiet village where every building stands a single story tall, and finding among them, impossibly, a tower rising miles into the sky. With the materials and the time available, it simply should not be there, and yet there it is. This great structure is a gentle and humbling reminder that we are still beginners in our study of the cosmos, students who have only just begun to read the first pages of a very long and very old book. The Great Wall of Hercules Corona Borealis whispers to us that the universe is more intricate, more surprising, and far older in its workings than our present equations can fully explain. It stands at the ceiling of our known reality, the furthest frontier of matter, the last great landmark, before we lose ourselves entirely in the immensity of everything. It is the largest single thing we know, and here at last we have reached the top of our long climb. Before we turn toward home, let us pause at this great height and look back down the whole length of the ladder we have climbed, very slowly, the way you might pause at the top of a long hill and gaze back at the path winding far below. Begin here at the Great Wall, 10 billion light years from end to end, a structure so vast it nearly defies the laws we know. Step down to the long knotted chains of filaments, and the great Shapley supercluster, and our own Laniakea, the immeasurable heaven, with its 100,000 galaxies all flowing softly toward a hidden heart. Step down again to the Virgo supercluster, and then to the Virgo cluster, that glittering city of galaxies. Down once more to our own local group, the small family of more than 50 galaxies that includes the great spiral of Andromeda, whose light set out before our kind existed. Down to the Milky Way itself, our home, 100,000 light years wide, turning slowly in the dark. Down to the quiet arm where our sun drifts among hundreds of billions of others. Down to our small solar system, mostly empty, an island of cool matter in an ocean of fire and light. Down to the Earth, a pale speck of dust several steps from a melon-sized sun. Down to the ground beneath that Earth and the room you are resting in and the bed that holds you. Down to your own hand and the skin upon it and the cells beneath the skin. Down to the molecules and the atoms, each one almost entirely empty, a tiny marble at the center of a great quiet stadium. Down to the nucleus and the quarks within it, held fast by their invisible glue. Down to the points of pure presence that cannot be divided. And down, at the very bottom, to the trembling foam of the Planck length, the floor of reality, where distance itself dissolves. From the smallest tile of space to the greatest wall of galaxies, it is all one continuous staircase connected to the last, every scale woven from the same handful of pieces and ruled by the same gentle laws. And somewhere in the middle of it all, neither the largest thing nor the smallest, resting comfortably between the foam at the bottom and the wall at the top, is you, not lost in the vastness, but threaded through it, a single quiet point where the whole enormous staircase has somehow folded back upon itself and become aware that it exists. We have traveled an extraordinary distance together, you and I, from atoms that are almost pure emptiness, held open by invisible hands, all the way out to walls of galaxies measuring untold trillions of miles across. In the face of such an overwhelming display of size, it would be easy and entirely understandable to feel small to the point of vanishing, to feel like a tiny and unimportant accident, a speck of dust that the vast cosmos would never even notice were it to disappear tomorrow. But the deeper truth, the one worth carrying with you into sleep, is far kinder than that. We are not simply trapped inside the universe, peering out at it through a small window, separate from all the grandeur. We are part of it, woven into it, made of the very same fabric as everything we have seen. Everything we have traveled through tonight, from the trembling foam at the base of reality to the filaments of the great cosmic web, all of it obeys the very same laws. There is not one kind of physics for great structures and another, lesser kind for you. The oxygen filling your lungs as you breathe slowly now, the calcium that hardens your bones, was cooked in the same kind of stellar fires that gave rise to the galaxies of that distant wall. We are not tourists in the cosmos, not outsiders who wandered in by mistake and ended up in a quiet corner of the Milky Way. We are connected to the most distant things there are by an unbroken thread of matter and energy that has never once been severed since the very beginning. When we look out at the great chains of galaxies or feel the pull of the great attractor, we are, in a sense, looking at our own history written across the sky in letters of unimaginable size. These structures are the result of billions of years of slow cosmic unfolding, a story that began with a single spark of energy and, after an immensely long journey, arrived at last at something truly remarkable. Eyes that can look up at the sky and minds that can wonder about it. Although the observable universe reaches outward across a radius almost too large to write down, perhaps the most amazing thing in all of it is simply this, that a creature as small and soft and fleeting as a human being should be able to measure that distance at all. It does not matter how grand the stage may be if there is no one present to tell the story. For all our fragility, we are the mirror in which the universe is finally able to see itself. We are part of a great and patient cycle in which energy is forever being borrowed and returned and borrowed again. Stars die so that planets may be born. Planets cool so that life may one day take hold. We are the result of a long and improbable chain of gentle accidents that has allowed us to be here, tonight quietly asking questions about the origin of everything. To be alive is, in its deepest sense, to take part in a conversation the universe is having with itself. Every time we learn something new about a distant galaxy, about the nature of dark energy, about the smallest pieces of matter, the universe gains, through us, a little more awareness of its own quiet secrets. In the end, the great scale of the cosmos is not really a measure of how small we are. It is a measure of how far matter has come, across 13 billion years and more, to arrive at something able to think and to wonder. Everything out there, no matter how immense, is made of the very same substance as you. The next time you step outside and feel the sun rest gently upon your face, you might remember that this light traveled 93 million miles across the dark just to touch your skin. You might remember that every atom within you once dwelt at the heart of an exploding star, and that you belong to a vast cosmic web that joins the smallest things to the largest. The universe is an almost absurdly enormous place. That is true, but you possess the astonishing ability to look upon it and to wonder why it is there at all. And when you marvel at the immensity of that final great wall stretched across the sky, it is, in a way, the universe marveling at its own architecture through the soft and curious workings of your mind. We are, quite simply, the way in which the cosmos has at last opened its eyes to look upon itself. We are the gathered consciousness of ancient stars, the quiet voice of the galactic filaments, and the beating heart of a story that began nearly 14 billion years ago. And so, in the end, to understand how vast the universe is really only to understand how vast we ourselves have become. So let the numbers fade now, and the distances soften, and the great walls of galaxies grow dim and quiet in the mind. There is nothing left to measure tonight, nothing left to reach. You have traveled from the smallest grain of reality to the largest structure ever found, and back again, and now you can simply rest in the middle of it all, held gently by the same invisible forces that hold the stars in their courses. The universe is still turning, slowly, patiently, far beyond this room. The galaxies are still drifting, the light is still traveling, the long, quiet dance goes on, asking nothing of you. You can let it carry on without you for a while. You can let your breathing slow, and your thoughts grow soft and far away, and your body sink a little deeper into rest, knowing that you are a small, warm, living part of something immeasurably old and immeasurably large, and that you are exactly where you belong. Rest now. The stars will keep their watch. and the cosmos, vast and gentle, will hold you while you sleep.